Have you ever wondered what happens when you send a message or press play on a video? It's not magic. It's something far more real. We live our lives connected to a world we cannot see, a place that exists everywhere and nowhere, all at once. There lies a hidden infrastructure. Think of it as a city that never sleeps. It is the backbone of our modern civilization. This invisible city is powered by colossal secret buildings, data centers. They are the cathedrals of the 21st century. They are the silent, powerful hearts of the internet age. The invisible city would crumble into digital dust. Every time you search for something online, you're sending a request. A tiny, weightless question that travels at nearly the speed of light. It journeys to one of these data centers. Inside, a machine finds your answer in a fraction of a second. It then sends that answer all the way back to your screen. This happens billions of times every single day. A constant, rhythmic pulse of questions and answers. It is the heartbeat of our digital existence. A rhythm so steady and reliable that we have come to take it completely for granted. Think about the scale of this operation. It's almost beyond human comprehension. Every minute, hundreds of thousands of hours of video are uploaded, millions of messages are sent, countless transactions are completed. All of this information needs to be stored. It needs to be organized, protected, and made available instantly. This is the monumental task of the data center, to manage an endless, ever-growing flood of data. It's like trying to build a library that can hold every book ever written, and then adding a new wing every single second. These facilities are the guardians of our collective memory. The photos of your family vacation, the blueprint for a new skyscraper, the medical records that could save a life, the global financial system that depends on split-second trades. All of this resides within the secure walls of data centers. They are built to withstand earthquakes, floods, and power outages. They are defended by layers of physical and digital security. Their purpose is to ensure that our data, our digital lives, are safe. They keep the world's information safe from chaos. But these powerful hubs are more than just storage lockers. They are where the raw material of information is transformed. They are where artificial intelligence is born and trained. They are where complex scientific problems are solved. They are where new forms of entertainment are created and delivered to billions of people. They are the factories of the information age, churning out the services and innovations that define our time. They are not just storing the present, they are actively building the future, one byte at a time. How did we get here? How did we build this invisible world that now powers our real one? It didn't happen overnight. The story of the data center is a story of human ingenuity. It's a journey that spans decades. It starts with machines the size of a room that had less power than the phone in your pocket. It is a tale of relentless innovation, driven by our ever-growing need to process, store, and share information. It's a story about us, and our desire to connect with one another in new and powerful ways. To understand our digital present, we must travel back to its analog past. We must go back to a time before the internet, before personal computers, before the cloud. We will start our journey in the era of mainframes. These were the giants of the computing world, hulking machines that filled entire rooms, tended to by technicians in white lab coats. They were the original data centers, the ancestors of the sleek, massive facilities we know today. They were the first step on a long road. From there, our story will take us through a revolution, the revolution of the personal computer. We will see how technology moved from the corporate computer room into our homes and onto our desks. This shift changed everything. It created a new demand for shared information and connected services. It set the stage for the biggest explosion of information in human history, the birth of the World Wide Web. We will explore how this explosion created a desperate need for a new kind of data center. Join us on a journey through this secret history. We will uncover the evolution of these technological marvels, from the first humming mainframes to the birth of the internet, and finally to the rise of the cloud, a concept that has once again transformed our relationship with data. This is the story of how we built the invisible city. It is the story of the data center, a story that explains the hidden mechanics behind the screen you are watching right now. It is the story of the modern world. Our story begins in the 1950s or 60s. The air hums with the sound of immense power at work. This is the era of the mainframe computer, behemoths of metal and vacuum tubes that occupied thousands of square feet. These rooms were the very first data centers. They cost millions of dollars, a fortune at the time. Only the largest corporations, government agencies, and universities could afford them. They were the first machines to truly grapple with big data. Raised floors hid a tangled spaghetti of thick cables. Dust was the enemy. These drives with their spinning reels looked like something out of a science fiction movie. This was the primordial data center. Interacting with mainframes was a privilege. Access was strictly controlled. The operators were a special class, the high priests of the mainframe era. Often in white lab coats, they understood the machine's languages. Operators managed magnetic tapes following schedules. Systems programmers maintained operating systems. Application programmers solved business or scientific problems, submitting work and waiting for results. Results printed on green and white paper. The mainframe was a processing factory, a remote oracle. You waited for its wisdom. This controlled computing laid groundwork for interactive systems. Before data was fed to tape drives, it had to be captured. The primary medium was the punch card. Each card had 80 columns and 12 rows. Information was encoded by punching holes. Key punch operators would type data, and the machine would punch holes into a blank card. These stacks represented a program or data set. Decks of cards were fed into a card reader. It was slow and prone to error. Data was a physical artifact. It had weight and volume and had to be protected from physical damage. Even in this era of centralized giants, the first seeds of our connected world were being planted. The mainframes were islands of computation, but it wasn't long before people started thinking about how to build bridges between them. The idea was revolutionary. What if a user didn't have to physically walk their punched cards to the computer room? What if they could access the mainframe's power from a distance? This led to the development of the first computer terminals. These were not computers themselves, they were essentially just a keyboard and a screen or a teletype printer. These dumb terminals, as they were called, were a major breakthrough. They connected to the mainframe over dedicated telephone lines. A user could now type commands and see responses in near real time, a process known as time sharing. The mainframe's powerful processor would rapidly switch between the requests of many different users, giving each one the illusion that they had the machine all to themselves. This was a radical departure from the slow, one-at-a-time, batch processing model. It was the first hint of the interactive, multi-user experience that would later define the internet. This development began to change the very nature of the data center. It was no longer just a sealed-off factory. It was becoming a central hub, a service provider that could extend its computational power outwards. The data center was now responsible not only for running jobs, but also for managing dozens, or even hundreds, of simultaneous user connections. This required new, more sophisticated operating systems and a new focus on networking and communications. The walls of the computer room were, figuratively speaking, beginning to dissolve. This concept of sharing a centralized resource among many remote users was the fundamental principle that would eventually lead to the internet and cloud computing. The early networks, like the ARPANET, which was developed in the late 1960s, were built to connect these large institutional data centers. The goal was to allow researchers at different universities to share the processing power of their rare and expensive mainframes. They were not yet building an invisible city for everyone, but they were laying down the very first streets. The age of isolated giants was slowly giving way to an age of connected hubs. The reign of the mainframe giants could not last forever. They were slow, bureaucratic, and incredibly expensive. A new generation began to ask, what if you didn't need a massive machine to do useful computing? This was the beginning of a rebellion of machines. It was the dawn of the mini-computer. The mini-computer, pioneered by companies like Digital Equipment Corporation or DIC, cost a fraction of a mainframe. This meant that smaller businesses and university departments could afford their own computer. They could break away and control their own destiny. Power was beginning to decentralize. They were also designed to be more interactive and fostered a more collaborative style of computing. This decentralization had a profound effect on the idea of a data center. Now, smaller computer rooms began to pop up all over the place. Imagine you are an engineer in the 1970s. For years your work has been bottlenecked by the central mainframe. You submit your designs as a stack of punched cards and wait for days to see the results. But now, something has changed. Your department has just purchased a shiny new mini-computer. It sits in a small air-conditioned room just down the hall. It is your computer. It serves your team and your team alone. This was a feeling of liberation. It was a surge of computational freedom that unleashed a wave of innovation across countless industries and fields of study. With a dedicated mini-computer, A department could manage its own data. It could run its own specialized applications. Financial departments could run their accounting software. Manufacturing divisions could manage inventory control. Scientists could run complex simulations. The software was often tailored specifically for the machine and the department's needs. This created a new ecosystem of software developers who wrote programs for these smaller, more agile systems. The one-size-fits-all approach of the mainframe was giving way to a world of specialized computational tools. This departmental computing model created new challenges for data management. Before, all of the company's data lived in one place, the central mainframe's tape library. Now it was scattered across dozens of mini-computers in different buildings, or even different cities. How do you share information between the accounting department's computer and the sales department's computer? This problem gave birth to the first local area networks, or LANs. Technologies like Ethernet were developed specifically to connect these departmental mini-computers, allowing them to share data and resources. These early networks were the first steps toward the connected enterprise we know today. The data center was evolving. It was not just a place to house a single computer but a node on an emerging network. The job of the computer operator was changing too. They now had to be network administrators, responsible for keeping the connections between these departmental systems running smoothly. They were no longer just feeding a single beast. They were becoming the zookeepers of a growing collection of smaller, interconnected creatures. The complexity of the invisible city was growing. The rebellion of the small did not stop with the mini-computer. The next wave aimed to put a computer on every desk. In the late 70s and early 80s, Apple and IBM introduced the personal computer, or PC. These were machines small enough to fit in your home and affordable enough for an individual to buy. This was the ultimate act of decentralization. At first, these personal computers were isolated islands. The solution was to connect these new personal computers to the existing departmental networks. The PC was no longer just a standalone device, it became a window into a larger, shared, digital workspace. This shift had a dramatic impact on the nature of the data center. It now had to support hundreds or even thousands of personal computers. The invisible city was experiencing a massive population boom. As personal computers flooded into the workplace, a new type of computer began to emerge. It was not a giant mainframe, it was not a departmental mini-computer, and it was not a desktop PC. It was a machine designed with a single purpose, to serve the needs of the other computers on the network. This was the birth of the server. A server was essentially a powerful personal computer, but without a dedicated screen or keyboard. It was designed to sit in a back room, running around the clock, managing shared files, handling email, or hosting a database. This led to the creation of a new kind of miniature data center, the server closet. Almost every office in the 1990s had one. It might have been an actual closet or just a dusty corner of a spare room. Inside, you would find a handful of these new beige or black server towers. They were often stacked haphazardly on a metal shelf, surrounded by a chaotic tangle of network cables, power strips, and blinking hubs and switches. The gentle hum of their cooling fans became a familiar part of the office soundscape. This was grassroots data infrastructure, built out of necessity. These server closets were the unsung heroes of the PC revolution. They were the glue that held the new digital office together. They allowed teams to collaborate on documents stored in a central place. They ran the email systems that were rapidly replacing paper memos. They hosted the internal company websites that were beginning to appear. The person responsible for this closet was often just a tech-savvy employee, the IT guy who knew how to get things working. They were the mayors of these tiny, decentralized digital towns. But this model also created a new kind of chaos. With servers scattered in closets all over a company, it was a nightmare to manage. Security was often weak. Backups were inconsistent. Cooling was inadequate, leading to frequent overheating and crashes. Companies soon realized that this distributed mess was inefficient and risky. They needed to bring order to this chaos. They needed to consolidate these scattered servers back into a centralized, professionally managed environment. This realization set the stage for the next great evolution, the transformation of the data center to handle the explosion of the internet. The 1990s brought a profound change, redefining human communication. It was the birth of the World Wide Web. Suddenly, the network opened to the public. People could connect to a universe of information. This was about connecting everyone to everything. The first websites were simple, but a revelation. Now, data centers had to serve the entire world. Businesses could reach customers in every corner of the globe. Companies scrambled to establish their presence online. Hosting a website was a serious, mission-critical operation requiring specialized facilities. The need for a new, more powerful type of data center was born. It was the foundation of a new global economy. It was the digital storefront, the global marketplace. They were turning inside out, becoming powerful engines designed to serve the entire planet. The late 1990s dot-com boom triggered a frenzy of investment in internet startups. Every new company needed a place to host their website, servers, and somewhere to put them. This demand sparked a gold rush for companies providing infrastructure, the birth of the commercial data center. Companies like Exodus and Equinix didn't sell products. They sold space, power, and bandwidth in massive, secure buildings. Startups could co-locate their servers in these facilities, relying on robust power, cooling, and connectivity. Data centers became industrial-scale, windowless fortresses near internet backbones, with tight security and layers of authentication. Inside, cages housed servers for different companies, a physical manifestation of the internet's structure. The industry exploded to keep up with demand, converting old factories and building new facilities at breakneck speed. Every digital business needed a physical home, and data centers became the picks and shovels of the digital gold rush. These facilities were the silent partners of the dot-com era, providing the real estate for the new economy. The data center industry's rapid growth mirrored the chaos and ambition of the dot-com boom. Without these silent fortresses, the internet revolution would have had nowhere to live. The gold rush was on, and the data center was the new frontier. The messy server closet was out, the 19-inch rack was in. This steel frame, with standard mounting holes, let companies stack dozens of flat, rack-mountable servers in a single, organized column. The data center floor became a landscape of tall, black monoliths, rows of racks arranged in precise aisles. This wasn't just for looks, it enabled efficient power, networking, and cooling. The rack system introduced modularity. Companies could rent a quarter, half, or full rack, expanding as needed. Networking gear and storage fit the same standard, turning the data center into a giant set of Legos for engineers. Cable management became an art, with every wire cut to length and routed for airflow and troubleshooting. Clean cabling improved cooling and made maintenance easier. The data center evolved into a place of precision and discipline, far from its chaotic origins. The rack brought order, density, and scalability to the digital world. The age of the rack was the age of industrial computing. The future would only get denser. Dense racks of servers brought two huge challenges: power and heat. Each server consumed electricity and turned it into heat. 40 servers in a rack became a powerful space heater. Data centers needed massive power connections, on-site transformers, and backup systems like UPS batteries and diesel generators for 100% uptime. Cooling was even tougher. Old methods failed, so the hot aisle cold aisle layout became standard. Cold air was pumped into cold aisles, sucked into servers, and hot exhaust was vented out through hot aisles. Industrial-scale air conditioners, cracks, lined the walls, often using chilled water and cooling towers. The cost of cooling rivaled the cost of running the servers themselves. The data center became an energy-hungry life support system for machines. Power and heat defined the limits of digital growth. Every watt counted, every degree mattered. The battle against heat was relentless, only the most efficient survived. By the mid-2000s, the data center industry was mature, but giants like Amazon and Google needed more. Off-the-shelf servers and rented racks were too slow and inefficient for their scale. They began designing everything themselves, custom servers stripped to essentials, optimized for performance and efficiency. The entire data center became a single integrated system network, power, cooling, and servers working in harmony. New cooling techniques like using outside air and custom networking gear pushed efficiency further. The real breakthrough was software, layers that managed thousands of servers as a unified pool. Applications could be deployed, workloads shifted, and failures handled automatically. If a server died, the system didn't blink. Workloads moved seamlessly. This abstraction of software from hardware was the key innovation that made the cloud possible. The data center was now a programmable machine. The future was software-defined. The cloud was about to be born. The rules had changed forever. In the early 2000s, Amazon realized its world-class infrastructure could be a service for everyone. In 2006, Amazon Web Services launched, offering storage and virtual computing on demand. This was the birth of cloud computing, renting servers by the hour, no hardware required. Startups could launch instantly, scaling up or down as needed, paying only for what they used. The barrier to entry vanished. Small companies could compete with giants. Elasticity became a superpower. Launch 100 servers with a click, shut them off when demand dropped. Google, Microsoft, and others followed, building their own global cloud platforms. These hyperscalers constructed colossal data center campuses worldwide, wherever power and land were cheap. Each facility housed hundreds of thousands of servers, all run by a single company. The new gold rush was for hyperscale infrastructure. The cloud era had begun. The cloud isn't in the sky. It's a global network of hyperscale data centers, linked by high-speed fiber across continents and oceans. When you use a cloud service, your data runs on a physical server in a real building. The magic is the software layer that hides this complexity, making the world feel like a single computer. Now your photos, documents, and software all live in the cloud, accessible anywhere. Software is no longer installed. It's a service known as SaaS. Virtualization lets one physical server run dozens of virtual machines, maximizing efficiency and flexibility. This is time-sharing, scaled to the planet. The cloud offers not just servers but databases, AI tools, analytics, and global content delivery on demand. Anyone with an internet connection can access these powerful digital tools. The hyperscale data center is a factory for digital services. The world itself has become a computer. The future is everywhere and it's always on. The rise of the cloud has become invisible. It has woven itself into our daily lives so seamlessly that we rarely even notice it's there. Almost everything you do online now touches a cloud data center. This is why your phone can perform seemingly magical feats. This transformation has affected every industry. We are all constant and heavy users of these massive data centers. Planet-spanning data centers provide the invisible foundation for our digital society. It has disappeared from view, becoming a ubiquitous invisible utility. We have journeyed through time to the age of the cloud. Vast, interconnected data centers form the unseen foundation of our world. Think about our reliance on this infrastructure. We've built a digital twin of our civilization. The more essential data centers become, the more invisible they must be. Appreciate the journey that made it possible. The sum of human knowledge is available at your fingertips. The story of the data center continues, driven by relentless innovation. The explosion of AI demands new computational power, pushing data center designs to their limits. Sustainability is a key challenge as these facilities consume vast resources, increasing their environmental footprint. The next chapter will be green, with innovations in cooling and renewable energy powering the cloud. We're also seeing data centers fragment, with edge computing bringing them closer to data creation. From vacuum tubes to AI, data centers constantly reinvent themselves to meet our needs. They are the heart of our digital future, a future we build together, one byte at a time.